acceleration due to gravity. To understand this more, we'll explain an experiment done on a table tennis ball in page 28. When an object is dropped, it accelerates. Now, to understand this more and how it happens, we're gonna see this experiment. The experiment in figure 3.12. It shows a sequence of images of a falling table tennis ball taken with a time interval of 0.1 seconds between each image. We notice from the figure that the distance between two successive positions of the ball increases, which implies that the ball accelerates. Now here we have forces acting on the ball that are gravitational force or weight, and that it is pulling it downwards, and we have the air resistance pulling it upwards. Now if we neglect the air resistance, the only force affecting the ball will be the weight. We can calculate the acceleration of the ball using measurements taken from a full-scale version of an image such as figure 3.12. To get the acceleration, we need to get the final velocity and the initial velocity, and the time, it is a constant of 0.1 seconds. Now we can get the final velocity from using the equation speed equals distance over time, v equals d over t. Since in this experiment we have the time and we can get the distances between each position. Now let's start with the second and third positions of the ball. The distance from the book, we get it's d equals 14.7 centimeters. Now we convert this to meters by dividing over 100, so it becomes 0.147 meters. The time taken is 0.1 seconds, so the average initial velocity u equals the distance over time, which is equal to 0.147 meters over 0.1 equal to 1.47 meter per second. Now the third and the fourth positions of the ball, also from the book we get the distance d equals 24.5 centimeters. We convert it to meters by dividing over 100, so we get 0.245 meters. The time taken t equals 0.1 seconds, so the average final velocity v equals 0.245 meter over 0.1 seconds, which is equal to 2.45 meter per second. And it is clear that the velocity of the ball increases at this position. Now to get the acceleration, a equals v minus u over t, we substitute the numbers 2.45 minus 1.47 over 0.1 seconds equal to 0.98 meter per second over 0.1 seconds, which is equal to 9.8 meter per second square. So we can say that the acceleration due to gravity, g equals 9.8 meter per second square. To make it easier, we just say that the g is equal to 10 meter per second square. So we can say that if there were no air to resist the motion of falling through it, all objects falling near the Earth's surface would accelerate at an acceleration of g equals 9.8 meter per second square. Now to clarify this more, we'll watch this video by pressing on the hotspot icon. We have an astronaut on the moon. He has a feather and a hammer. Now, the gravity on the moon is very low relative to Earth, and there is no air resistance. We know that a feather has a smaller mass than the hammer. Now, if he throws both objects, we'll see that both will reach the ground at the same time. So here he's throwing them. If you notice on the movement of both the hammer and the feather, they both reach the ground at the same time. This shows how air resistance affects the motion of objects.